Let's explore text processing with sed, a powerful stream editor designed for filtering and transforming text. It's an invaluable command line utility for anyone working with text data. Sed is used for parsing and transforming text, using simple or complex pattern matching. By the end of this tutorial, you'll be able to use sed to manipulate text files effectively. Sed, often referred to as the stream editor, is a versatile text processing tool. It reads text line by line, applies specified operations based on matching patterns, and then outputs the modified text. Sed functions as a filter within command pipelines, making it easy to integrate into complex workflows. Here's the basic syntax of sed. Sed followed by the operation, pattern, replacement, flags, all enclosed in single quotes, and finally the file name. For instance, to replace the first occurrence of the word Linux with Linux in a file named file.txt, the command would be sed s/linux/linux/defiled.txt. The S indicates substitution. The G indicates that all occurrences has to be replaced. Let's explore some fundamental sed commands. First, there's substitution, which replaces text patterns with new content. For example, sed s/old/new/file.txt replaces the first occurrence of old with new on each line. Adding a G flag like sed s/old/new/gfile.txt replaces all occurrences. Second, the print command, which allows you to print specific lines or patterns, use sed in5pfile.txt to print line 5, or sed in/pattern/pfile.txt to print lines containing a specific pattern. Third, the delete command used to remove lines matching certain patterns. Use sed 5dfile.txt to delete line 5, or sed /pattern/dfile.txt to delete any line containing the specified pattern. Finally, we have append and insert, which add text after or before matching lines. Use sed 3a/newlinefile.txt to append new line after line 3, and sed 3i/newlinefile.txt to insert new line before line 3. Remember, these commands can be combined with line numbers, ranges, or patterns to target specific parts of your text. Let's dive deeper into the substitution command. The syntax is s/pattern/replacement/flags. The S indicates substitution, then comes the pattern to match, the replacement text, and finally the flags to modify the behavior. Common flags include G to replace all occurrences globally, I for case-insensitive matching, P to print the modified line, and N to replace only the nth occurrence. For example, sed s/unix/linux/filed.txt replaces the first occurrence of Unix with Linux in each line. Sed s/unix/linux/gfile.txt replaces all occurrences. To perform a case-insensitive replacement, use sed s/unix/linux/gfile.txt. And to replace, for example, only the second occurrence, use sed s/unix/linux/2file.txt. Consider the input. Unix is great, Unix is powerful. After applying sed s/unix/linux/gi, the output is Linux is great, Linux is powerful. Now let's discuss address ranges in sed, which allow you to specify which lines a command should affect. You can apply commands to a specific line number n, to the last line using the $, to a range of lines n, m, or to a range relative to a line n plus m, which applies to line n and the next m lines. You can also use patterns such as /pattern/ to apply commands to lines matching a pattern, or /pat1/pat2/ to apply commands from where pattern 1 is found until pattern 2 is found. Here are some examples. Sed 3dfile.txt deletes line 3. Sed 2for-dfile.txt deletes lines 2 through 4. Sed $s/old/new/gfile.txt replaces text only on the last line. Sed /error/dfile.txt deletes lines containing error. And sed /start/comma/end/s/old/new/gfile.txt txt replaces text between lines containing start and end. Let's integrate regular expressions into set to perform more advanced pattern matching. Some common regex patterns include caret to match the beginning of a line, dollar to match the end of a line, dot to match any single character, asterisk to match 0 or more of the preceding character, to match any character within the brackets, caret to match any character not in the brackets, \w to match a word character, which includes letters, numbers, and underscores, \d to match a digit, and \s to match a whitespace character. Here are some practical examples. Sed /caret error /dlog.txt deletes lines starting with error. Sed $pcode txt prints lines ending with semicolon. Sed s/w*d \w*g file. Txt replaces words containing digits with number. Set n\w plus at \w plus \w plus /context. Txt prints email addresses. Finally, set s/caret *redacted /data. Txt replaces text enclosed in quotes with redacted. Capture groups are an advanced feature in sed that allows you to remember matched text and reuse it in replacements. You create a group using parentheses pattern and reference it with \n, where n is the group number. For example, to swap the first and last names in a file, use sed s/a**, /2 \1 /names.txt. To format phone numbers, use sed s/0 to 93, 0 to 93, 0 to 94, /1, /2 /3 /phones.txt. This rearranges a 10-digit number into XXXXXXX format. And to reorder a date from mm/d/woy to yymmdd, use sed s/0 to 92, /0 to 92, /0 to 94, /3 \1 \2 /dates.txt. As an example, transforming 555-123 4567 using the phone number formatting command results in 555-123 4567. There are several ways to execute multiple sed commands. You can use semicolons to separate commands within a single sed invocation. Alternatively, you can use multiple e-flags to specify different commands. Another approach is to create a sed script file with commands on separate lines, and then use the F option to execute the script. For example, using semicolons, sed s/foo/bar/g, s/baz/cux/jfile. Txt replaces all instances of foo with bar and bez with cux. Using multiple e options, set yes/foo/bar/yes/baz/cux/jfile. Txt achieves the same result. To use a script file, create a file such as commands.sed which might contain the lines s/foo/bar/g, s/baz/cux/g, and /error/d. Then run it with set fcommands.setfile.txt. For complex scenarios with address ranges, you can use sed /start/comma/nd/s/foo/bar/g, s/baz/cux/g, file.txt to apply the substitutions only within the line starting with start and ending with end. Let's explore some common sed command options that enhance its functionality. The in option suppresses the automatic printing of the pattern space. The e option adds a script to the commands to be executed, allowing you to chain multiple commands. The F option adds the contents of a script file to the commands. The I option edits files in place and can optionally create a backup if an extension is supplied. The R option enables extended regular expressions, and E is the same as R. And the S option treats files as separate entities rather than one continuous stream. For example, Set n/error/pa log file. Txt prints only the lines containing error. Set i.boc/old/new/g. config.txt edits config.txt in place, creating a backup named config.txt.boc. Set es/0 to 9 plus/number/data. Txt uses extended regular expressions to replace all numbers with number. Set fcommands.setInput.txt executes multiple commands from the script file commands.sed. Let's look at some practical set examples. To comment or uncomment lines, use set s/caret #/ servername // /1/http to uncomment, or set s/caret port/#port/ config.txt to comment out a line. To extract information, use set n/caret subject/pmail.txt to extract the subject line from an email file, or set ns/*ip /0 to 9 /1/plog.txt to extract IP addresses from a log file. To clean data files, set s/space plus / data.csv replaces multiple spaces with a single space, and set /caret$d file. Txt removes empty lines. For batch configuration, you can use set is/max_connections equals 100/max_connections equals 200/ s/timeout equals 30/timeout equals 60/settings onf to modify multiple settings in a configuration file. These examples show how set can be used for many text processing tasks. If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.